right, so what conjectures can you make about medians and altitudes of triangles? And then we're going to use medians to find the centroid and altitudes to find the orthocenter. Okay, so a median of a triangle is a segment from a vertex to the midpoint of the opposite side. And I don't know why, for some reason, I don't have a picture on here. So let's go ahead and draw a picture of what a median looks like. So first I'm gonna put us a triangle. Let's make it white because that's a little bit easier to see. All right, so here's my triangle. What is important to note that you won't be able to see when I draw this because you can only see the end result. But what is important to note is that the median is going to start at the vertex. Start at the vertex. So it's starting here. So it's starting here, and then it's going down, 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 okay? And that's important when we get to the centroid theorem to know that it starts at the vertex, okay? And then the median starts at the vertex and then it goes to the midpoint. So these two sides would be congruent because it goes to the midpoint, okay? So there are, of course, 3 medians in a triangle. So we've got 1 already there, 2, and 3. And these are congruent. And then where they meet, right there, smack dab in the center, that is your centroid. And I don't like centroid because I think it messes up all the other ones because you got circumcenter, in-center, orthocenter. Why is this one called the centroid? It just doesn't fit with the others because all the others have some kind of center. But we'll just go with it. All right, so the point of concurrency, which is the centroid, is on the inside of the triangle. So the good thing about the centroid, it is always on the inside. Next. So your centroid theorem says that the centroid of a triangle is 2/3 the distance from each vertex to the midpoint of the opposite side. So the medians of the triangle meet at point C. I should say point P, guys, not C. Let me fix that. I'm gonna just write it on there. P. I'll fix the card later. But the midpoint, the medians meet at point P, and so P is going to be my centroid. Now, it's important to note that it was bothering me, so I had to fix it. Okay. It's important to note that it has to go from the vertex. And I know that I keep saying that over and over again, but it makes a big difference because let's just specifically look at one median, okay? So here is one median from B to F, right? Okay, this portion that is here from B to P, then that portion is the 2/3. And so then that means that the portion that is here from P to F, then that portion is just 1/3. And if I go the other way, then the measurements don't work out. Okay, so you have to make sure that you're starting at the vertex, going to the centroid. That's the 2/3. Okay. All right, let's look at an example. So it says in triangle RST, point Q is the centroid, and SQ is equal to 8. Find QW and SW. So Q is the centroid. Let me get another color. Q is the centroid right here in the middle, or close to the middle, I'll say. And we know that SQ is equal to 8. Well, our centroid theorem tells us that SQ is going, because that's from the vertex to the centroid, is going to be 2/3 of the length of the entire median, which is SW. Okay? All right. So we know SQ already, we know it is 8. So 8 is 2/3 of SW. And then in order to solve this equation, we're going to multiply by the reciprocal. So if I multiply both sides by 3/2, then these 2's will cancel out to be 1, and these 3's will cancel out to be 1. So on the right side, I have SW. And then over here on the left side, 8 times 3 is 24, and then 24 divided by 2 is 12. So SW is equal to 12. That's one of the things we had to find. So that means that the whole entire length from here to here is 12. That looks awful. So from here to here, that whole entire length is 12. All right. And then we also need to find QW, because that's the other thing that we need to find. And if we know the whole thing is 12 and that SQ is 8, then that means QW has to be 4. Because 12 minus 8 is 4. Does that make sense? Do we have any questions? Let's keep it moving. One more example. This one says, find the coordinates of the centroid of RST with vertices 2, 1, 5, 8, and 8, 3. So I'm actually going to draw the triangle, and this one is going to be a little bit better because look, I have like some lines that can help me out. It's going to look better than the last ones I've been drawing, because I know they didn't help me bad. I got some lines this time to help me. I need at least 8. That's 8. So I'm going to go 9. I need at least 8 here. Barely enough there. All right, so R is 2, 1. And S is 5, 8. This is 2, and then 8. 3 is 2. All right, so pretty nice triangle. I do say so myself. Okay, so I have a triangle. Now, if I'm finding the centroid, that means I need to go from the vertex to the middle of the opposite side to get my medians. So let's go ahead and get my medians. So I'm going to get all 3 of them. So I'm going to start with the median, the midpoint of RS. And so that's going to be equal to 2 plus 5 over 2, comma, 1 plus 8 over 2. So that means it's going to be equal to 7 over 2 and 9 over 2. And then I'm going to get the midpoint of RT. And so that's going to be 2 plus 8 over 2 and 1 plus 3 over 2. And so that's going to be 5, 2. And then I need the midpoint of ST. And so that's going to be 5 plus 8 over 2 and 8 plus 3 over 2. And that's going to be 13 over 2 and 11 over 2. All right, so these are all my midpoints, right? So I'm going to go ahead and plot them. I'm going to plot them in red. So I got 7 over 2, 9 over 2, which is 3.5, 4.5. So 3.5. 4.5, that's going to be about right there. I got 5, 2. 2 is right there. And then I got 6.5, 5.5. So 3, 4, 5, 6 and a half. 1, 2, 3, 4, 5 and a half. All right. Okay. So we got RST. Let's call this X, Y, and Z. And then I'm going to draw my lines to each of these. All right, does everybody follow me so far? Okay, so this is Z. Oops, that didn't work. This is the one I picked for Z. This is 6. This is Y. All right. Okay, so let's be realistic. We need to find this point right here, right? Okay. What's going to be the easiest line to use to find that point? The line that I have that is SZ, right? This is a straight line. Looks good. So we're going to use that one. So we know that Z is 5, 2. Right? And so our centroid theorem says that, let's call this center, because we don't have a name for it. Let's call this center C for centroid. Okay? So our centroid theorem tells us that the length from S to C is equal to 2/3 the length from S to Z. Does everybody follow how I got that? The length from S to C is 2/3 of S to Z. Make sense? Okay. So what is the length from S to C? We don't know yet. That's what we're trying to figure out, right? Well, what is the length from S to Z? 6, right? Because from 8 to 2, that's going to be 6. All right? So we're going to multiply by 3/2 on both sides. No, we're not. We're just going to do the math. 2/3 of 6. 2 times 6 is 12. 12 divided by 3 is 4. So the distance from S to C is 4. So what does that make point C? 5, 4. So then our centroid is 5, 4. I'll write it over here.